Okay, so I'm on my way towards running Grble control under Linux. There's a version you can download and it's complaining about GTK headers and being annoying. So I went to the GitHub and downloaded the code, which runs in Qt Creator. That doesn't compile right away either on my system. It's complaining about bad declarations of is not a number. The only thing you have to do there is integrate a line. Let's see if I can bring it up here. Include math.h. Every file that references not a number or is not a number needs that in the header, and then it builds. So, what can we do now? Let's see if we can connect to this thing. Serial port error, invalid baud rate. Okay. Ah! Let's try this one again. I could swear I heard the thing going. Ooh! It is going. Look at that. Let's put spindle on. It turns it on, but it runs way too slow. Okay, so I really just rewatched my own video and it said speed 1000. My PC is a bit slow because I'm currently rendering the video that you have seen before this. We're in a time warp. Yeah, spindle speed, maximum 1000. Floop floop. We say 1000. We say on. Whee! So, as an FYI, we have FlatCam running under Linux. This wasn't easy. It's Python program, so you would expect it to just work. However, it depends on Python Qt4, and that last ran, I think, in Ubuntu 16.04. So there are two options to get it running in the modern Ubuntu. This is Ubuntu 20 something something. You either make a virtual machine, which I did, and then I could get the FlatCam Python stuff to run. And I had the crazy idea to make an app image out of it. That didn't work. And the simple solution is to git branch to the beta, and that actually seems to run under 20.4. So this is all cool. The beta from 2011. That's good enough for me. We need to do isolation routing. Calculator. My tool is 0.3. It has an angle of this. We want to cut 0.1. So the diameter becomes 35. Okay. Then we do 4 passes with an overlay of this. That looks quite good. We can get everything out. A bit of warning, after some experimenting and lots of failures, I found out the following. You're in your project, you select your copper layer, you do the isolation routing, and you end up with a geometry object. From this geometry object, you can now create a CNC object. But you have to be careful with your preprocessor. So the program normally sets it to default, and then you end up with a CNC object And if you look in the code editor, you will see that it issues M6 commands. And the comments here tell you that this is a command that tells the CNC machine to change its tool. Now, our CNC machine doesn't have a tool changer. So when you tell it to change the tool, which is apparently go home and deliver the tool to a holder and grab another tool, the CNC 3018 just goes, what? And stops. And the rest of your G-code, which means the rest of your routing, is not going to happen. So you don't want M6 commands in your CNC object. And therefore, when you go to your geometry, preprocessor, you select default with no M6. And then you end up with a G-code that looks like this. A bunch of comments. And M0 that the machine also doesn't understand but happily ignores. But you see here, no put the tool down and load another tool commands. So this will actually work. And therefore, once you find out these little things, it's good to make them permanent by going to Preferences. Then you go to Geometry, Create CNC Job, and you change the preprocessor to default no M6. Apply and save. Now the next time you will not be surprised by this again. Alright, update. I'm getting ready to cut my first board. I took a little sacrificial piece of wood, which is screwed down to the main board, and I screwed the board down to the sacrificial bit. And you will see it's not flat there. You can clearly see it's coming up and down. So everybody is telling you to make a height map. And for a height map, you need a height map sensor. This is where you'll find A5 directly on the big 0.1 inch header. That's where the cable goes. Here we go. Green cable on the spindle, black cable on the board. This should work. Yes, I'm finally making a height map. There is setting in the menu. Height map probing feed that you need to set to something, and I set it to 100. And now it's finally probing.
Engage.
Alright, full disclosure, that's my first fail. Multiple fails there. First of all, I forgot the height map, which I carefully made and then didn't apply because there's a little thing you have to click. Secondly, somewhere in the middle, the CNC machine just stopped, so I restarted it, and then it went over its own tracks, but it erased them. So yeah, that's a definite fail. Not to mention the third fail, which is that this one was in a mirror image. So then I started this one, which looked really good, but you see that this trace is okay going up, okay going at 45 degrees, but then here it's completely gone. I don't have a macro, guys, I can't zoom in any further. So that's interesting. So that wouldn't be my bit that's screwed up there. It's just my spacing. So we'll see if we can make those wires a little bit wider. So here you see I've redesigned the board a little bit. First of all, I've made the traces wider. But I also put the traces closer together, because when you start to learn about CNC, you figure that you want to actually cut as small as possible. So putting these traces further apart is not going to do you any good. You won't get any extra isolation because you want to run a low number of isolation routers. And you will just end up with a giant copper island between your tracks. So I put them closer together. Here they are a little bit further apart. Not sure what that will do, but if we turn on the CNC plot, you now see that it has to do far less work. This is actually only one pass, and it removes pretty much exactly what is needed, and you already have overlap between some of the CNC routes. So turns out that the trick here is to make the paths as wide as possible, and on this very simple circuit board there is no reason to not make them at least 1 millimeter wide. Except for here where it has to go between a few pins. So this track is, I think, the only track that's 0.5 millimeters. And I start to think that doing CNC routing actually makes you a nicer circuit board designer, in the sense that you start to generate designs that are easier to fabricate, and even if you send them to a board house, the board house will be grateful. I also made a CNC file for a second pass. Should the first pass not yield enough isolation, this file only does the second pass, carves out space between these tracks and these little islands here. We only will use this if necessary. Well, third time's the charm. First circuit board, no height map and mirrored. Second circuit board, trace being too narrow. As you can see, I have redesigned the circuit board. So what I've learned is that the traces can be fairly close together. You just have to make them a little bit thicker. And by putting them roughly as close together as your tool width, it means that you only need one pass to cut out the space between the traces. So this milled pretty well. You can see that the features on the date are actually not visible very well. That's actually because this drill bit is pretty much gone already. I rammed it into the circuit board a few times, so I think the tip is a bit rough, not as sharp as should be, and probably it's milling wider than I'm telling the program. Another thing that happened right in the middle of milling is that the serial communication stopped, and I was about 3/4 through the file and I didn't feel like restarting it. So what I did in the gribble control is I removed all the lines from the G-code that gave me a result OK. I left the spindle where it is. I restarted the spindle and I gave the command F100, which is the feed rate I was working, and then I resumed it and it worked. I was super surprised. So, second pass is done. You see here it did clean up some of the stuff, made it a little bit nicer here as well. Let's see what happened here. It's not entirely gone, but definitely a little bit better. Now to run this in second pass is not ideal because you get minor X, Y, Z offsets, but I think I got away with it. I have finally taken delivery of a set of drill bits, 2 of each, because I'm fairly sure I'm going to destroy them. Alright, I have discovered a few other things that I'm documenting for you as much as for me. So here we have the drill layer, and when you open that up in the drill editor you will see that there are 2 tools, and if you will generate CNC code like this, it will tell the CNC machine to first load this tool, drill these holes, then change the tool and drill the bigger holes. Again, we don't have a multi-tool CNC, so we have to edit this and we have to make one CNC file per tool. So you go to the drill editor. You remove the second one. You only keep one drill in there. And then save it. And then you go to the drilling tool. I think my board is 1.5 millimeter or 1.2 only, so I'm drilling 1.7 to make sure I go through it. I do it in 3 steps. We don't want to break our drill bits immediately. When traveling between one hole and the other hole, we have to go up Z by 2 millimeters. You also have to start at a little bit of a Z, otherwise it will go from your 0 position to your first hole and it will just scrape away the trace. Ask me how I know. Feed rate 100 is good. Spindle speed, we found out already, 1000 is good. And then here at the end, the preprocessor, for reasons I don't really understand, cannot be the no M6, but it has to be tool change custom. We'll look at the code this generates. There are, for some reason, still M6 commands in there. Look at the G code. But I found out this is the one that works. At least there are no M0 commands here, which I think is put the tool down. M6 is put the other one in. You know, if you want to find out by yourself, try all the preprocessors. This is the one that worked for me. So then in the project, you end up with 2 drill files, one for the 3.2 and one for the 1.1. And you end up with 2 drill CNC jobs. And you run them one after another. And that should be good. So it works after I separated out the drill file. You need only 1 tool per drill, and these little mounting holes require a different drill, so I need to make a different CNC file. And look at that! It's brutal. Here we go. Oof. Maybe you should redo the Z rate next time. Oh. And that is that one. The final CNC file you need to make is the edge cutouts. This is the least problematic in my experience. You take the edge Gerber file if you have that. Otherwise it can do it automatically, but it's easier if you have your actual edge file. And you go into Cutout tool, choose a bit that you have. I think I chose 2.4. Here you have to tick convex shape. How deep is it gonna cut an edge around the board? -1.8. Do it in multiple layers. You don't want to ruin your bits. The margin to the board, 0.1 millimeter. The gap size. So we cannot simply cut out the entire board, because then right at the end, the whole board will start shaking and vibrating. It needs to be kept in place while the edge cut is doing it. So we're going to place several gaps in the edge that we can then later cut out with some pliers. 4 gaps is pretty usual. You can place them automatically, at which point they'll get to the middle. If you are scared that it will make your board weak or something, you can place them somewhere else. You could, for instance, place them here, and then here and here. That would work, or here would be fine. If you do it automatically, it will just look like this. These nice round edges are only happening when you tick convex shape. So, and then finally, when you have that geometry, you have to generate the CNC file from it. Check all your parameters. If they are by default set to stupid values, change your preferences, because you will be surprised by it. Cut Z -1.8 in multiple steps. Travel above the board, don't scratch up the board. Feed rate XY 100 is conservative. Z, whatever. Spindle speed of 1000 is just the maximum. We don't have any tool change parameters, but we have to set the preprocessor. Again, in this case, tool change custom. The M6 didn't work for me. I tried the other ones. This is the one that works. If you don't believe me, check it out for yourself. Generate the CNC and run it. Getting ready to do the cutout routing with a 2.5mm bit. Pattern is gonna be like so. It's loaded in gribble control and let's go. Send it. Gerd! That shows a very low feed rate. We're also doing 3 passes. Definitely a few mistakes were made, but you know, for a first one, come on. And she's out. So you see that the holes went right through, which is great. We have a circuit board. Well, holes are done. Holes are good. Even though I used a 1mm, which in retrospect was probably a big one, I made the pads 2mm and I lined it out. I'm gonna have a look at this under the microscope, clean it up a little bit. We'll see where we are. So here we have the board after some polishing and some rework. Clearly the quality is gonna get better in the future, but some of the things I had to do is scratch away a little bit of leftover copper there. The problem is when you mill away stuff and you leave a tiny trace, that tiny trace ends up wiggling back and forth, so it was touching this trace sometime and then the other and then the other, effectively short-circuiting the 2 traces. Here is a clear defect where I had the drill standing here. The first drill hole was over there, but it was standing at Z0, so it scraped across the board and then started drilling here. So there are a couple of paths I will have to restore. So yeah, some stuff that shouldn't be connected is connected, and some stuff that should be connected isn't connected. So as far as circuit boards go, this isn't the best. But as far as just fart around with the CNC for a few days goes, I'm not super disappointed. I think I've learned a lot. There's just a lot of procedures that you have to have in place and things you have to remember, and it's just like 3D printing in that regard. So let's get this board populated, shall we? So board is built, populated. As you see, I had to make 2 bridges and I didn't want to do it by hand, so I just bought a CNC machine. Why not? Next step is to spray this thing, because this copper is going to go very dull and I don't want that, so I bought special spray to protect it. Let's look at that. PCB varnish, PCB luck, whatever you call it. Varnish. Let's finish this. Programmed a little bit, now I've got a running rainbow, and this whole thing seems to be working just fine. Circuit board is behaving a blast. Enclosure is printed and ready to go. And looks like we came to the end of the project.